Well, now we're going to start section 10.4 after we've gotten comfortable with the fact that we can have a polygon that has an enclosed amount of area. And now we're going to measure that area. And we're going to be using formulas that you need to write as you view the video. Especially if we want to complete the homework. So let's begin. I've put in a picture, and it shows a beautiful area. And this is some form of gathering, rest area. So, and the question is, how many people can the restaurant hold? Well, the ratio of space to volume and area are all key components to the general use of geometry in our everyday life. So let's begin. So we're going to be looking at some formulas, and they are basic polygons. And what basic, we're talking about squares, rectangles, parallelograms. So, as we begin our study of these formulas that help us determine space within a containment, such as a polygon, we have area of a parallelogram is base times height. Okay, so if I have a parallelogram, I have this perpendicular drawn to the base, which is the height, and this is the base times height. And what happens is these two end areas make the square occur, or the rectangle. The area of a rectangle, which is the more popular, remember we talked about it being the shoebox, is area is length times width. And again, it's the same as height times base. And then we have the one of the square. And the square has, recall, all four sides of a square are equal. So we can say then it is area is side squared. Now, one thing we have to discuss is that the outcome of using these formulas is the notation as square units. As we look at this part, some of us are experienced and others are not in distinction. So what we're saying is I can have inches squared, feet squared, but I can't have square feet. This in front of the type gives the value squared, which then looks like a linear product. And that doesn't happen in area. Area is squared. So let's look at what we have here on our formulas. Here's a rectangle, and a rectangle has right angles, and it is length times width. A square all sides are equal. Therefore, it is side squared because it's the same as all of them are right angles. And that would mean this is the height and this is the base. And so we just say, since it's the same, side squared. So here is the study of that rectangle and the parallelogram. So the parallelogram has this shaded area that is cut from the rectangle and moved to the opposite side or flipped. Now this is area of a triangle. And it is 1/2 the base times the height, because what is happening is we're making a parallelogram out of it, and half of it is the opposite side. So then this one is the most unique. And I remember taking idiot tests to know proficiency in mathematics, and they always mention the word trapezoid. So let's review that. Trapezoid has one pair of parallel segments. That's really segments. And we call them the big base and little base. And these two items give us an opportunity to average out their sums. So we average out, we divide by 2 their big base and little base, and then times the height, so that we partition off what needs to come over here to make that rectangle occur. So I've always seen it as 1/2 big base plus little base times the height. But in this textbook, they wrote it as AB, knowing that these are parallel lines. So now we're going to do some examples. Our first step is to identify the shape, then use the appropriate formula for the shape in the calculator and to get the product, and then note the unit squared. So here we have a rectangle. And we know that the area is length times width. And in this case, our area is going to be 7 times the 19 meters squared. So now we're going to do the calculator. And I'm going to get 133, and this was in meters squared, or 133 square meters. But this is the more comfortable to do. And this implies area measurement, the inside of the polygon. So let's do another one. This is a square. You can tell it's a square because it's 9 and 9, and they're 90 degrees. So this is 9 inches and this is 9 inches. So this is a square. So area for a square is side squared. So area is going to be 9 squared. Area is 81 square inches, or 81 inches with a little 2 after it. All right. Nothing difficult. You've done this since grade school. This is a parallelogram. And it means that we have area, the formula, is the base times the height. Now the height is where the square is against the base. And the base is always the bottom value. So I'm going to have the 53 times the 46. And I'm going to use the calculator. And I'm going to have the 53 times the 46. 2,438 square, and this guy is in centimeters. Square centimeters. Centimeters squared or square centimeters. This is a triangle. So then we use the formula 1/2 base times height. So in this case, we're going to have the area equal to 1/2. The base is 12, and the height is 4. So I'm going to do this. 1/2 of 12 is 6 times 4. So the area is 24 square inches, or 24 inches squared. So now we're going to talk about the most optimum of area considerations, and that is a circle or a square. It optimizes how much area we have contained in the polygon. Well, then we have a special case called a circle. A circle is a set of points in a plane equally distant from the given point of the center. It's the radius. And the radius is a line segment from the center of any point in the circle. All radii in a given circle have the same length. A diameter, it cuts the circle into 2 equal halves. So we have the distance around a circle called a circumference. Which says it is diameter times pi, or 2 pi r, twice the radius, because 2 times the radius equals a diameter. All right? And then we have the area. Area is pi radius squared. So we have to only use the radius. And pi is an irrational number. Usually we put it as 3 1400ths for pi, approximate. All right. And on our calculator, we do the second ln key to enter what we need. Oh, that's wrong. That's a second up caret. Sorry about that. Isn't it? Let me look. That's a typo, big time. Yeah, second up caret is pi. All right. So that's wrong. So we want to find the circumference and area of a circle. Express the answers in terms of pi. Okay, if we use pi without the approximate value, it is called an exact answer. So we want first the circumference, and we have a radius given, 2 pi r. The circumference is 2 pi and times 10. So that would be 20 pi. So this is my in centimeters. It's distant, so it's only units. This is exact. Then we want to the nearest tenth. So I'm going to replace with the calculator second up caret and enter. All right, so let's do that before we go further. 20 second up caret. See how pi happens, and enter. And we want 62 and 8/10 centimeters is the approximate. Now we want area. And we have a radius given, so it's pi r squared. And it says, express the answer in terms of pi, then round to the nearest tenth. So we're going to put in 10 squared pi, and that equals to 100 pi. And this is in centimeters squared. This is the exact answer. Now we're going to do the approximate. Do that. Second up caret, enter. And we're going to have 314 and 2/10, and this is centimeters squared. So we have the approximate and we have the exact. Well, this one gives us a diameter. So we want to do the circumference first. So that's a diameter times pi. So then that gives me 14 pi. And this is an exact answer. Now we're going to do the approximation. And we'll use our calculator for that. And we're going to have 44 and no as an approximation. And no decimal, because we round to the 10th. And this is in, let's talk about our units, yards. So that's our approximation and the exact. Now we want area. Well, to get area, we need the radius. So we know 2 radiuses equal a diameter. So the radius is diameter divided by 2. And that means I have 14 divided by 2 equals 7 yards. All right. So now that we have our value of our radius, we can use our formula. So this one, I'm going to have area is equal to pi times 7 squared. And that'll give me 49 pi. And this is in yards squared. This is my exact answer. Now we're going to give the approximation. And we're going to use our calculator. One decimal, 153 and 9/10 yards squared. Nothing difficult, easy calculator usage. Now we have a composite figure. of a square and two circles. Okay, this part here and this part here create a circle. And this part here and this part here create a circle. And we're told there's a square in the center. So we know then that the diameter is 14 centimeters and that the radius is 7 centimeters. And we want to find the area of the composite figure. So we want the formula, right? We want area. We want area of a square and 2 areas of a circle. And because there's 2 circles and that. Now we can put in what we know. 14 squared gives the area of the square. 2 pi, and then my radius is 7 squared. So that's going to give me 14 squared plus, this is 49 doubled. And now we're going to give an approximation. This is 49 doubled is 1898, if I'm not mistaken. Let's do my math. Yep, 98 pi. Now we're going to do the whole thing on the calculator. 14 squared plus 98 second pi, and enter. And I get 503 and 9/10, and this is in centimeters squared. The area of 2 circles and the area of the square. All right, now we have the shaded area. Shaded area, we take the whole shaded and subtract the non-shaded area. And we have triangles. And so the area for a triangle is 1/2 base times height. All right. So we see that the base of the large is 27 millimeters. And the height, that's the base. And the height of the large is 8 and 16. So we have the big. Now the small, that's my dog, Sadie McGrady. She's got people out there. And then I want the small triangle. So the base is 9 millimeters and the height is 8 millimeters. So now I'm going to do my formula. So I'm going to have 0.5. My base is 27. My height is 24 minus 0.5. I'm doing the smaller one. my base is 9, and my height is 8 to give me area, shaded area. All right. Now we're going to just do the calculator. 0.5 times 27 times 24 minus 0.5 times 9 times 8. And we're going to have 288, and this is in millimeters squared, is my total area. So we have another one. Now this is a semicircle. That's 1/2 of a circle. And we have a triangle in terms, and we want it in terms of pi. Find the area inside the semicircle minus the outside triangle. All right. So we have a right triangle. Therefore, we know the height is 24. And we know the base, right? 32. Or we could find the base by doing the Pythagorean theorem, right? But it doesn't matter. We can use what we have. And then we have a semicircle. So we have 1/2 area of a circle. So that's going to be 1/2 of a pi radius squared. All right. So we're going to take 1/2 of that. So now we're going to construct the problem. So we want the semicircle area minus the triangle area. So I'm going to have 0.5 pi, and my radius, we have to look at the Pythagorean theorem. So I do have to do the Pythagorean theorem on this one. And we learned that in the previous section to find the diameter. So here we go. So we have the two legs, and we want the hypotenuse. So we're going to have 24 squared plus 32 squared equal to the hypotenuse squared. And then we're going to do the math. And I'll need my calculator. I'll move it over here. And I'll clear it. So I'm going to have the 24x squared plus 32x squared and enter. I'm going to take the square root to find the root value. Second x squared and put the 1600. 40 equals the c, which equals the diameter. I need 1/2 of the diameter to get the radius, and that's 20. All right. So now I have that. This is 20. Okay, so we have the semicircle is pi radius squared minus the triangle area, which is 0.5 base times height. And it doesn't matter which one I put. Multiplication is commutative. So I'm going to do my calculator. And I'm going to do, and I want pi first, right, in terms of pi. So this is 5 times 20 squared. It's 2,000 pi minus the triangle. 0.5 times the 24 times the 32. And I get 384. Now this is my exact area. And this is in inches squared. Now I'm going to do the approximation. 2,000 pi minus 384. And I'm going to get 5,899 and 2/10 inches squared is my approximation. All right. Nothing difficult. Just think clearly. Follow the pattern. So here is an application problem. That means something you would use if you were knowing what you needed. What will it cost to carpet a rectangular floor measuring 15 feet by 21 feet? And it costs $22.29 per yard. All right. Well, first off, need the measurements in yards. And we studied this in chapter 9. So we know 3 feet equal 1 yard. So I'm going to have 15 feet times 3 feet equal 1 yard as an equivalent conversion. And then I'm going to have 21 feet times 3 feet equal 1 yard. And what this does is cancel my feet, and I end up with yards. And then I'll have the measurements I need. So this becomes 5 yards, and this one becomes 7 yards. So now I need the area. We calculate area of the rectangle. Well, a rectangle is length times width. So I've got 5 times 7. Area is 35 square yards. And it sells at $22. Now we want the cost of the carpet. So to get the cost of the carpet, it's square yards times cost per yard. All right, so per square yard. All right, so we have 35 times the 22.29. And we're going to use our calculator. And we're going to enter the 35 square yards times the 22.29 per square yard. And it's going to cost us approximately $780.15 to purchase the carpet. That's it. It's cheesy easy. Do the homework, follow the patterns, and you should do very well. Make sure you keep all the formulas on some form of sheet for when you take the exam. Thank you for listening.